Question 1. Through careful analysis of system behavior, a technician named Mr. Alvarez notices that a newly installed smart thermostat intermittently loses communication with the HVACR unit during peak demand hours. Upon closer inspection, he finds that the thermostat is using a 24th common wire, C wire, provided via an external transformer. The customer's HVAC system has variable speed blower motor and is already integrated with other smart home devices over Wi-Fi. What should Mr. Alvarez prioritize as the most effective solution to resolve the communication issue without compromising system compatibility? A. Install Y-range extender between the thermostat and router to enhance signal strength. B. Replace the smart thermostat with battery-powered model that doesn't rely on the C wire. C. Rewire the HVAC control board to supply dedicated C wire from the system's internal transformer. D. Disable the variable speed function of the blow-up motor to reduce system complexity. Answer. Correct answer. C. Explanation. A dedicated C wire ensures stable power to the thermostat, especially under heavy load conditions. Variable speed motors require consistent low voltage control communication, which can be disrupted by external transformers or poor wiring. Per NEC Article 725 and manufacturer specifications, smart thermostats must be powered via reliable Class 2 circuits. Disabling the variable motor reduces efficiency and violates ASHRAE 90.1 standards. Using a battery model introduces maintenance issues and doesn't resolve power inconsistency. A Y extender may improve signal but not correct power delivery issues. Question 2. To what extent does understanding the differences between Z-Wave and Zigbee influence network reliability in a smart HVACR installation? Both protocols operate on the same frequency, so they are interchangeable in all applications. Zigbee is better for HVACR systems because it uses more power and longer range per device. Z-Wave operates on a less congested frequency and supports more robust mesh networking for HVAC controls. Zigbee networks self-destruct when signal interference occurs, making them unreliable. Answer. Correct answer. C. Explanation. Z-Wave uses the 908.42 MHz band in the U.S., reducing interference compared to Zigbee's 2.4 GHz. This enhances reliability for mission-critical HVAC functions. Zigbee offers faster speeds, but is more prone to congestion in Wi-Fi-heavy environments. According to E802.15.4 standards and Zigbee Alliance, both protocols support mesh networking, but Z-Wave often yields better results in residential HVAC settings. Statements and diet incorrect or exaggerated. Question 3. Considering the evidence, a smart home technician named Ferguson is configuring a system that integrates HVACR data with third-party energy management platforms. The homeowner expresses concern over data sharing and wants assurance about privacy controls. What is Ferguson's best course of action to maintain ethical compliance and protect customer data? A. Recommend disabling all third-party integrations to ensure no data is shared externally. B. Inform the homeowner that data sharing is standard and cannot be restricted once integrated. C. Enable privacy settings, anonymize data if possible, and ensure the platform complies with DDR or applicable U.S. privacy laws. D. Use the homeowner's wide credentials to access their router and manually block outbound HVACR data. Answer. Correct answer. C. Explanation. Ethical practice demands data protection. GDPR, California Consumer Privacy Act, CPA, and FEC guidelines emphasize informed consent and transparency in data use. Ferguson should ensure encryption, minimal data exposure, and third-party compliance. Disabling integration may defeat the purpose of smart tech, misleading the client. B. Violates ethical and legal norms. Manual router modification. D. Is intrusive and may violate terms of service or user trust. Question 4. In light of recent developments, which of the following best explains why certain smart HVACR systems are designed to restrict operation when refrigerant charge falls below a threshold level? A. To protect the thermostat's internal sensors from exposure to extreme temperatures. B. To avoid compressor damage and ensure compliance with EPA Section 608 refrigerant handling regulations. C. To maintain network stability and prevent data transmission errors in smart sensors. D. To reduce the likelihood of user complaints due to noise during low charge conditions. Answer. Correct answer. B. Explanation. Low refrigerant levels can cause the compressor to overheat or fail. Smart systems can detect pressure changes and automatically restrict function to prevent damage. This also supports EPIS Section 608 rules requiring proper refrigerant maintenance to prevent leakage. Smart diagnostics align with ASHRAE 15 for safety. Options A, C, and D do not address the real risk or regulatory compliance involved. Question 5. During the process of scheduled maintenance, HRConquer attempts to update the firmware of a smart hub that manages multiple HVACR zones. Midway through the update, the homeowner accidentally unplugs the device, resulting in a corrupted system state. Which of the following is the most appropriate action to take? A. Factory reset the smart hub and manually repair each HVACR zone controller. B. Bypass the smart hub and use direct wiring to control HVACR zones. C. Call the manufacturer to request a replacement hub due to firmware corruption. D. Use a secondary device to flash the firmware over Bluetooth using recovery mode. Answer. Correct answer. D. Explanation. Many smart hubs include a recovery mode that allows firmware flashing via Bluetooth or USB. This avoids full reinstallation and maintains device mapping. Per manufacturer protocols and support documentation, recovery mode is often used for interrupted updates. Factory reset is time-consuming and risks configuration loss. Bypassing the hub. B. May violate design intent. Replacing the hub. C. Unnecessary unless recovery fails. Question 6. One might argue that not all smart thermostats are universally compatible with multi-stage HVAC systems. What primary compatibility feature should a technician verify before installation? A. Whether the thermostat has a touchscreen interface for customer ease of use. B. That the thermostat can handle multi-speed fan controls independently. C. The ability of the thermostat to modulate heat pump balance points. D. A number and labeling of wiring terminals and support for multiple heat-cool stages. Answer. Correct answer. D. Explanation. Multi-stage HVAC systems require thermostats with multiple dedicated terminals. Ability depends on wiring interface and internal logic to modulate stages properly. NEC 110.3b and manufacturer documentation require compliance with labeling and operational support. Options and B are user experience related but not functional. C is relevant for hybrid systems but is secondary to terminal support. Question 7. Illustrated by the integration of automated blinds with smart thermostats, how can this setup contribute to enhanced HVACR performance? A. By allowing users to adjust blinds remotely using their smartphones. B. By enabling thermostats to control lighting schedules in occupied rooms. C. By coordinating sunlight blocking with thermostat operation to reduce heating cooling loads. D. By turning off HVAC systems when blinds are closed to save energy. Answer. Correct answer. C. Explanation. Smart blinds integrated with HVACR controls help reduce thermal gain loss from windows. When linked with smart thermostats, they can lower cooling load in summer or retain heat in winter. This aligns with ASHRAE 90.1 energy efficiency standards and supports intelligent load management. Option D oversimplifies automation logic, and B offer convenience, not performance optimization. Question 8. The primary reason for using cloud-based remote diagnostics in smart HVACR systems is A. To allow homeowners to monitor technician schedules. B. To enable energy companies to restrict HVAC use during high demand. C. To proactively identify performance issues and initiate troubleshooting before failure occurs. D. To reduce the cost of manual inspections by avoiding licensing requirements. Answer. Correct answer. C. Explanation. Remote diagnostics collect performance metrics, detect anomalies, and notify technicians or users before breakdowns occur. This improves uptime and supports predictive maintenance models as outlined in ANSI ASHRAE Standard 180. Options and B as secondary features. D is incorrect. Licensing and inspection requirements still apply. Question 9. focusing specifically on the integration of smart HVACR and security systems, which potential failure mode must technicians account for during system design. A. The possibility of thermostat temperature readings being ignored during security events. B. The complete shutdown of HVACR systems if a camera loses power. C. Network bandwidth prioritization causing delays in HVAC command execution during surveillance uploads. D. The heating system sending alerts to police during emergency mode. Answer. Correct answer. C. Explanation. Security systems may use high bandwidth, especially when uploading video. If the same network serves the HVACR system, this could delay commands or diagnostics. Technicians must implement quality of service cost protocols to prioritize traffic. Ignoring this can result in performance issues. This is consistent with smart home networking best practices per EN-CEDIA guidelines. Question 10. Given the circumstances, a customer contacts Mr. Hargrove about a smart thermostat displaying inconsistent humidity readings, leading to erratic dehumidifier activation. What should Mr. Hargrove do first to address the issue effectively? A. Replace the humidity sensor with one of a different brand. B. Calibrate the sensor using manufacturer-recommended tools and compare readings to a reference sensor. C. Disable the humidity control function to prevent unnecessary activation. D. Reinstall the thermostat in a different room away from airflow. Answer. Correct answer. B. Explanation. Sensor calibration is the first logical step. Comparing it with a reference ensures accuracy. Placement and brand could matter, but calibration is non-invasive and standardized. Disabling Control C is a workaround, not a solution. Relocation D should follow calibration if needed. A manufacturer guidelines and ASHRAE 55 calibration must be verified before hardware replacement. Question 11. In a modern context of integrated HVACR systems, Hensley is installing a smart thermostat in a retrofit project where the home has legacy ductwork and inconsistent room temperatures. The homeowner has requested automation that adjusts airflow to compensate for hot and cold spots. After assessing the system, she recommends adding smart zoning dampers and sensors. Which potential challenge should Hensley anticipate with this setup? A. Increased static pressure and undersized ductwork leading to blower strain. B. Reduced dehumidification performance due to excessive fan speed. C. The smart thermostat losing Wi-Fi connection in each zone. D. The dampers automatically closing during filter replacement. Answer. Correct answer. A. Explanation. Smart zoning can improve comfort, but in older duct systems not sized for zoning, closing dampers increases static pressure. This can strain the blower or cause short cycling, violating manual D account and ASHRAE 62.1 airflow standards. Proper bypass design or variable speed motors can mitigate this. B is a side effect but not primary. C and D are unrelated. Question 12. By evaluating user behavior patterns, Mr. Darnell integrates temperature and occupancy sensors with a central HVACR control panel. However, the homeowner complains that heating still runs in unoccupied zones. What should Mr. Darnell do to optimize energy usage without reducing occupant comfort? A. Replace occupancy sensors with motion detectors for better accuracy. B. Just control logic to enable zone-based operation using sensor data hierarchies. C. Rewire the system to disable the thermostat in unused rooms. D. Set all sensors to manual override mode to eliminate false readings. Answer. Correct answer. B. Explanation. Smart zoning requires control logic that prioritizes occupancy sensor data. Using sensor hierarchies ensures rooms are only conditioned when occupied, reducing energy use. As per ASHRAE 90.1 and CEDIA guidelines, this enhances efficiency and may help but doesn't solve control logic flaws. C is inefficient and D defeats automation purpose. Question 13. From a practical standpoint, which tool is most appropriate for diagnosing an intermittent low-voltage fault between a smart thermostat and an HVACR control board? A. Infrared thermometer to check for hot spots behind the wall. B. Clamp meter to measure line voltage only. C. Multimeter with continuity and voltage drop testing capabilities. D. Vacuum gauge to test for refrigerant pressure anomalies. Answer. Correct answer. C. Explanation. Low voltage faults require continuity and voltage drop testing, which only a multimeter can provide effectively. NEC Article 725 emphasizes Class 2 wiring diagnostics for smart HVACR thermometers and vacuum gauges are for thermal and pressure testing. Plant meters don't measure millivolt circuits reliably. Question 14. To illustrate this point, Istanuan connects a smart thermostat to a heat pump with electric auxiliary heat. During testing, he observes that the auxiliary heat activates even when outdoor temperatures are only mildly cool. What is the most likely reason for this behavior? A. The heat pump's reversing valve is stuck in heating mode. B. The thermostat's control algorithm lacks outdoor temperature compensation. C. The defrost control board is damaged. D. The backup heat relay is installed backwards. Answer. Correct answer. B. Explanation. Many smart thermostats require configuration to use outdoor temperature data to lock out auxiliary heat. Without this, it activates prematurely, lowering efficiency. This violates Energy Star thermostat guidelines and increases energy bills. Reversing valves and relays wouldn't consistently trigger aux heat. Defrost board impacts cooling cycle. Question 15. Contrary to popular belief, integrating HVACR alerts with smart security systems involves more than basic notifications, which integration risk must be mitigated to maintain operational and cybersecurity integrity. A. The security system disabling HVACR functions during firmware updates. B. Thermostats sending excessive data to security logs. C. Remote HVACR commands being intercepted if encryption protocols are not applied. D. The HVACR system becoming the default trigger for the home alarm. Answer. Correct answer. C. Explanation. Cybersecurity threats can exploit weak encryption between smart devices. HVACR commands can be intercepted or spoofed to ESSL encryption, MAC filtering, or secure keys aren't used. This aligns with NIST cybersecurity framework. Options A, B, and D are edge case issues without major system impact. Question 16. While examining a large smart home retrofit, Istran finds that the smart lighting system interferes with HVACR commands. The HVAC system occasionally fails to respond to thermostat inputs. What should she do to resolve this issue and restore proper functionality? A. Install a separate router dedicated to HVACR devices. B. Convert the thermostat from Y to Z-Wave communication. C. Reduce the lighting automation schedules to free up bandwidth. D. Reassign IP addresses using static allocation to avoid IP conflicts. Answer. Correct answer. D. Explanation. IP conflicts can result in packet loss or command failure. Assigning static IPs ensures consistent network behavior for mission-critical HVACR systems. This complies with CEDIA and ISP network design standards. Using separate routers introduces complexity. Converting protocol B may not be supported. Question 17. The fundamental question is how smart thermostats interpret thermodynamic data in multi-zone environments. Which sensor integration helps balance temperature discrepancies due to heat stratification in large rooms? A. Occupancy sensors mounted on doors. B. Humidity sensors placed near return ducts. C. Wireless temperature sensors placed at multiple elevations. D. Static pressure sensors inside the supply trunk. Answer. Correct answer. C. Explanation. Heat stratification causes temperature variance between floor and ceiling. Multi-elevation sensors enable thermostats to average or prioritize readings, improving comfort. This supports ASHRAE 55 on thermal comfort. Static pressure and humidity sensors serve different functions. Occupancy sensors detect presence, not temperature. Question 18. Across different scenarios, smart home technicians must educate clients on the capabilities and limits of smart HVACR systems. When explaining the benefits of geofencing to a homeowner, what key points should be emphasized? A. Geofencing uses manual scheduling to reduce energy usage. B. It allows the homeowner to turn off the HVAC system from any location. C. It uses the homeowner's GPS location to automate HVAC settings for comfort and efficiency. D. It sends data about the home's usage patterns to the thermostat manufacturer. Answer. Correct answer. C. Explanation. Geofencing use GPS data to adjust settings when the user is away or returning home. This maximizes comfort while reducing energy waste, aligning with DOE recommendations for energy automation. It's not based on manual schedules A and doesn't require user interaction like B. D may raise privacy concerns. Question 19. With respect to predictive maintenance, Mr. Lopez sets up a remote diagnostics platform for a commercial smart HVACR system. He receives an alert that compressor amperage has steadily increased over 2 weeks without a corresponding temperature drop. What is the most likely root cause? A. A firmware update failed to optimize compressor logic. B. The evaporator coil is dirty, reducing heat transfer efficiency. C. The Y module is underpowered and delaying commands. D. The thermostat is in vacation mode, limiting cooling power. Answer. Correct answer. B. Explanation. Rising amperage with poor cooling suggests reduced heat exchange, commonly from dirty coils. This causes compressors to work harder. Smart systems identify such patterns as part of condition-based maintenance in ANSI 180. Options A, C, and D wouldn't cause mechanical load increase. Question 20. In comparison with traditional HVACR systems, what building code consideration is essential when installing smart HVACR components in a new construction project? A. Ensuring the smart thermostat is battery powered only. B. Installing Y extenders in all rooms for compliance. C. Verifying that all low voltage wiring meets NEC Class 2 circuit requirements. D. Using extension cords to power hubs during testing. Answer. Correct answer. C. Explanation. NEC Article 725 requires Class 2 wiring for smart HVACR low-voltage components, ensuring safe operation. All connections must use certified conductors with proper insulation. Battery-only thermostats, they aren't requirement. Using extenders, B, or extension cords, D, doesn't meet permanent wiring codes. Question 21. Upon closer examination of a retrofit installation, Mr. Castillo finds that a smart thermostat intermittently reboots, especially when the HVAC fan cycles on. The system uses shared control wiring for multiple smart sensors. Which of the following is the most likely cause of the issue? A. The thermostat's battery backup is not charging properly. B. The system transformer is undersized for the cumulative smart load. C. The Y router is interfering with the thermostat firmware. D. A nearby light switch is introducing electrical noise into the circuit. Answer. Correct answer. B. Explanation. Smart thermostats and sensors draw more power than traditional devices if the transformer cannot support the current load, typically 40 V for multiple devices. The thermostat will reboot under load. NEC 110.3b and manufacturer guidelines recommend proper transformer sizing. Options and D are less common. C is unrelated to power delivery. Question 22. The development of smart HVACR platforms has enabled advanced energy profiling. Is Valdez analyzes a home with 3 zones, each using occupancy and temperature sensors. What data combination provides the most accurate insight into zone level efficiency performance? A. Humidity levels and HVAC runtime. B. Return air temperature and ambient light level. D. Occupancy patterns and energy consumed per BTU delivered. D. Number of Y disconnects and outside air temperature. Answer. Correct answer. C. Explanation. Efficiency at the zone level is best measured by energy usage in relation to conditioned output, factoring in occupancy for demand-side relevance. This aligns with ASHRAE 211 energy auditing practices. There's 2 general, B lacks load relevance, and D is peripheral. Question 23. When analyzing firmware update failures in smart HVACR devices, which precaution is essential before initiating the process on a critical HVACR controller in a multi-zone commercial system? A. Temporarily disabling the HVAC system safety relays. B. Disconnecting all remote sensors to isolate the update. C. Verifying network uptime and power stability to avoid incomplete installation. D. Setting the controller to factory defaults prior to flashing firmware. Answer. Correct answer. C. Explanation. Firmware updates require stable power and uninterrupted connectivity. Failure mid-process can break the device or corrupt configurations. Following manufacturer protocols and industry best practices, verifying stability beforehand prevents system downtime. Disabling relays or resetting systems prematurely violates safety protocols. Question 24. During the process of configuring a smart HVACR system, ISTA Oberlin enables alerts for filter changes, low refrigerant pressure, and temperature anomalies. However, the homeowner reports receiving false alarms, especially at night. Which steps should ISTA Oberlin take to reduce nuisance notifications while maintaining safety? A. Disable all alerts after 10 p.m. using Do Not Disturb mode. B. Limit alerts to email only, avoiding real-time mobile notifications. C. Adjust threshold sensitivity and introduce delay logic in the alert configuration. D. Replace the thermostat with a simpler model lacking alert functionality. Answer. Correct answer. C. Explanation. Smart platforms allow tuning of alert sensitivity and delays to avoid false positives. ASHRAE Standard 135. BACnet recommends defining logic thresholds for automation, disabling alerts, say, or reducing visibility. B. Risks missing real issues. Downgrading hardware. D. Negates the benefit of smart diagnostics. Question 25. The prevailing attitude towards smart HVACR control systems is that they simplify user experience. Yet ISTA Singh notices that a home with multiple voice assistants experiences inconsistent thermostat control. What integration factor must be addressed to stabilize functionality? A. Set all assistants to the same language pack. B. Prioritize one voice assistant as the primary control protocol to avoid conflicts. C. Limit white channels to one band, 2.4 GHz for all smart devices. D. Remove the thermostat from the mobile app to force voice control preference. Answer. Correct answer. B. Explanation. When multiple assistants control the same endpoint, command collisions or overwrites can occur. Designating one as primary reduces API conflicts per Matter protocol and Amazon Alexa smart home guidelines. Redundancy must be managed. Why tuning? C. Helps range, not logic. D. Removes user flexibility. Question 26. Among the various calibration procedures, ISTA-LIO is tasked with verifying that a humidity sensor in a return plenum is reading accurately. What is the proper way to perform this calibration? A. Compare readings with a calibrated hygrometer in stable ambient conditions. B. Spray mist directly onto the sensor to simulate high humidity. C. Use a thermostat to reset the sensor and evaluate trends over 24 hours. D. Block off duct airflow to ensure no draft during testing. Answer. Correct answer. A. Explanation. Best practice requires comparing sensor output to a reference device in a stable environment. This supports ASHRAE 62.2ix standards and ensures HVAC decisions are based on reliable data. Spraying water. B. Can damage the sensor. Trend watching. C. Lacks precision. Blocking ducts. D. Introduces artificial conditions. Question 27. Through the lens of smart technology education is Holbrook Trains. A new homeowner on the smart HVACR dashboard. The homeowner is confused by the energy use charts and feels overwhelmed. What is Holbrook's best approach? A. Refer the homeowner to the user manual for independent study. B. Customize the dashboard view to highlight daily trends and simple comparisons. C. Disable all analytics features until the homeowner becomes more comfortable. D. Suggest replacing the smart thermostat with basic programmable one. Answer. Correct answer. B. Explanation. Simplifying data visualization improves engagement. Highlighting daily trends fosters understanding of consumption without overwhelming the user. According to DOE energy literacy standards, visual feedback should be intuitive. Options. And D. Abandon user support. C. Removes the value of smart analytics. Question 20. Looking at the data on device adoption, ISTA raises designing a unified smart system that includes HVACR, lighting, blinds, and occupancy sensors. Which central component best supports interoperability across multiple manufacturers and communication protocols? A. A proprietary cloud account from a single manufacturer. B. A Bluetooth-based controller that pairs with devices. C. A Matter-compliant smart home hub with multi-protocol capability. D. A mobile app that supports geolocation tracking. Answer. Correct answer. C. Explanation. Matter is an industry-standard protocol for interoperability across brands and networks. Zigbee, Z-Wave, Wi-Fi, etc. ensures reliable control and unified automation. As per CCEL's Matter protocol standard, it's the future of smart integration. Proprietary systems limit flexibility. Apps and Bluetooth have narrow scope. Question 29. One might argue that wire instability is the most common point of failure in smart HVACR setups. A technician is dispatched after user reports delayed thermostat responses and remote disconnections. What diagnostic step is most effective in isolating the issue? A. Temporarily turn off all other smart home devices. B. Replace the thermostat with a hardwired controller. C. Conduct a network packet loss test and measure signal strength near the device. D. Change the thermostat's language settings and reboot. Answer. Correct answer. C. Explanation. Network diagnostics tools allow measurement of latency, signal strength, and packet loss. These metrics isolate weak links in communication and follow E800 2.11 best practices. Turning off devices A may help short-term but doesn't diagnose root cause. B is unnecessary. D has no effect on connectivity. Question 30. What would happen if a third-party platform is granted full control of a smart HVACR system without proper API configuration and permission structure? A. The system would fail to report error codes to the user. B. The HVACR unit would default to emergency shutdown. C. Conflicting commands could override manufacturer safety limits. D. The thermostat would permanently lose user scheduling preferences. Answer. Correct answer. C. Explanation. If API permissions aren't scoped correctly, third-party apps can issue commands that conflict with built-in logic, possibly overriding limit switches or enabling stages unsafely. This violates all 60730 safety standards and OE API usage terms. Emergency shutdown. B. Only occurs in response to faults, and D. are less impactful.